we've got a product rule here, u times v, so we use the product rule. dy dx, u dv. Now, this second part of the product is of itself a function of a function, so it's u dv plus v times du, and that differentiates to 2x. So here we have to differentiate the subproblem. E to the something function of function rule differentiates to e to the something multiplied by the something differentiated, which is 4. So we end up with 4x squared e to the 4x plus 2x e to the 4x. We could tidy that up if we wanted with some algebra. So let's have a look at the next one. Again, it's a product. So dy dx, use the product rule, is u times dv, and that's a subproblem, plus v times du, and that's a subproblem. And these subproblems, I better move this out of the way to give us a bit more room. These subproblems, u dv, it's something squared, isn't it? So something squared, u squared, differentiates to 2u multiplied by the something differentiated, because it's a function of a function, 3x plus 1. And then it's plus v, wasn't it, times du. Something cubed, u cubed, that would differentiate to 3u squared multiplied by du dx, which is the something differentiated too. And that was 2x plus 1, wasn't it? So what have we got? We've got 6, 3x plus 1, 2x plus 1 cubed, plus 6, 3x plus 1 squared, 2x plus 1 squared. Looks like it. Okay, good. And we could simplify that with a lot of algebra, couldn't we? But I'm not going to worry about that here. Now this is a quotient, u over v. So dy dx then. Let's have a go at this one. We need to use the quotient rule. So it's v x squared minus 1 squared times du dx minus u, this, times dv dx, all over v squared. This squared would be squared is power u times is 4. So it was v du dx. This is a subproblem, it's u squared, isn't it? That differentiates to 2u, 2 of u, multiplied by the something differentiated, 2x, minus v times du dx. Oh, sorry, v du dx minus u times dv dx, that's right. Something squared, u squared. So that would be 2u, which is this value here, multiplied by the something differentiated, 2x. And again, we could use all the algebra to tidy that up and get the answer, couldn't we? I'm not going to worry about that here though. Let's do the next one. It's the process that's the most important thing. The algebra is important, but it's the differentiation that's at the core of it all. So let's look at this one then. It's a product. So it's a u dv plus v du, isn't it? So it's u. Now I'm going to write the dv straight away. Differentiating this, sine of something, sine u goes to cos u, multiplied by du dx, which is a half. So that was u dv plus v times du, and this just differentiates to nothing and minus 2x. So that's that one. And again, we could tidy that up a little bit with algebra. Now this one then. Okay, let's see what we've got. Log of something. It's a function of function, but the something is a quotient. So we're going to look at that in due course. So in the first instance, it's log of something. So you think of all of this as the u. So dy dx then. Log of u goes to 1 over u. Multiplied by the something, this differentiated. And this derivative now is a quotient, isn't it? So we'll have v times du minus 2x minus u times dv all over v squared. Squared. There we go. And we could tidy that up with algebra as well, of course. And it would all tidy up. This would, one of these would cancel with one of those would go, and we could tidy up and expand this bracket. But in principle, that's the solution there.